Okay, so it's a great pleasure to be here at National Center for Digital Sciences NTHU and talk about the exploring self-clear string theories and extensions. Okay, so these are based on the following papers with the Jaemo and the Seoul University and Jaemo here, and also and Teacher King at Postech, and also the same people. And Kyung is now the student at Seoul University of South Korea. So they are various speakers. And for the last several years, I'm interested in the gauge theory description of self-clear string theories. So I'd like to make some kind of the progress report at this place. And so I'd like to give some simple examples of the 2D gauge theory descriptions of self-clear string theories. And then I will talk about the instantary strings and the exceptional instantary strings. And then we will mention about the structures of the 6-stage strings and the general position. And then I will conclude and the future directions. So the basic motivation of this project is kind of rather the simple one. So in the mid-90s, the people have known about the so-called 0.1 gauge theory, which is a special type of the tension strings. So many of these kind of the 0.1 in the 6-dimensional quantum field theories arise in the M-theory or the F-theory setting. So this one arises when we consider this the M9 probability war, and we have this M5 rings, and if the M5 rings are coincident with the M9 rings, then it will give rise to the so-called 0.1 EA theory, which is a tension string with the EA global symmetries. So we know that we have known that this should be the interacting the 2-dimensional scope field theories, and so it's a long-standing puzzle. How can we describe the self-clear string theories? These are the puzzles not just specific to this kind of the strings, but also many of the self-clear string theories arises in the M-theory or the M-theory setting. And so, but I mean, this one is a rather convenient to deal with. So let me first explain this one. So the question is, okay, so our proposal is that one can define the tension string limit using the gauge theory configuration, which is related to the previous one from the type setup and going to the compact time limit. So when you have this kind of type A setup, which is kind of the unlimited, then we have this ND2s upon the compact time limit, you will turn into the M2 brains. And this NS5 brains turn into the M5. And then this the combination of the OA plus APAs, or the SO16 gauge group, they will turn into the EA gauge theory and turn into the M9 brains. So this is the kind of the Hana-Newton configuration where I'm going to specify the world volume directions of NS5 and the PA and OA. And from this one, you can see that there would be the SO4 global symmetry along the longitudinal directions of the NS5 and world volume, and also the 7 and 9 directions transferred to this one. So one can easily read off the meta content of the 2D theory. They will have the so-called 0.4 Rorschach symmetry, and the symmetry is SO4 or 3, 4, 5, 6, as I alluded to before, and also this SO3, 7, 8, 9 that transfers to the NS5 direction. And this can be turned into the SU to left, and SU to right, and SU to right, which will be used in specifying the meta content here. Essentially, the meta content is given by the O of N, the gauge group, because we start from the UN gauge theory, and we apply the ON coding. So we have this ON gauge group for the NTHU brains. And then we have this A mu, and then there are some right-handed fermions. Then we have this hypermultiplet, ON symmetric, which comes from the longitudinal motion, 3, 4, 5, 6 directions of the M5 ring. And there are some the Fermi the multiplets coming from the D2 and the DA sectors, which is given by this way. One can easily check that this meta contents would satisfy the anomaly cancellation of the 2D gauge theories. And then the interactions are determined by the force symmetry, but which we don't care at this moment particularly. Okay, so as an as an evidence for this one can work out the elliptic genus. The recipe is known by these guys. So with the choice of the 0,2, the worst is symmetry out of the 0,4, the elliptic genus is given by in this way, where the J1, J2 those are cartons of the SO4, 3, 4, 5, 6, and the JI, those are the cartons of the SU2, 7, 8, 9. And then we can also introduce a bunch of the chemical potentials for the SO16. So the elliptic genus gives the beta spectrum of the 60 theory and the whole genus of particle string amplitude and related collegiality. And so there are several quantities that is checked once after we compute this elliptic genus. And one of the important check here is the E8 global symmetry in the infrared indeed would arise. So the simplest one is just a single string, which is the Z2 gated theory. And then the computation is very easy, and then we have just 4 discrete polynomials on the T2, and the result is given by the delta functions. Interestingly, when you combine all of these 4 discrete polynomials, then one can obtain the E8 delta functions. So at this moment already, the E8 global symmetry is manifest. And if you just look at the detailed construction of this one, this is roughly half of the E8 times E8 vector string with the free-Chromian formulation with the GS projections imposed. And then we call the general string as a E string. So if we go to the higher E string, say the O2 gated theory, and then the calculation is a little bit complicated because we should sum over the 7 polynomial sectors. And so we have this kind of the complicated looking formula. And then still again we can check this indeed has the E8 global symmetry. Not only that, we can do the slightly better, not in this formalism, but the old work of the Hagiga, Local, and the Bapa, they obtain the form of this one using some of the E8 invariant functions appearing like A1, B2, and the E6. Actually, later I will briefly explain that when you consider this the elliptic genus of the self-dual string theories, this kind of structure is very general. And so the structure of the elliptic genus will be restricted by, severely restricted by the modular property of the elliptic genus. And then one can just have the finite basis to generate the rows of the basis. And then one can just know only the finite BPS coefficients. Then we can determine all of these elliptic genus. So this is just a part of the example like this one. And also one can check the higher string like O3 or the O4, then one can check this inside the known results of the topological string amplitudes. So this is one of the simplest example of the self-dual string theory where it admits, which admits the gate theory description. So the important lesson is that the apparently very complicated looking two-dimensional tensional string, but they can be defined in terms of the gate theory in the infrared. So this is very good because gate theory is the simpler or the familiar objects. While when you talk about this tensional string or generally the two-dimensional superconfort field theories, then we don't have not very good ideas about how this one. So this is a good way to define the tensional string, and then one might wonder whether there are several examples like this one. Also very similar or the familiar setting is when we consider the coincident M5 rings. This is especially the two coincident M5 rings. So when you consider the M5 rings and suspended the B2 rings, again if you go to the type 2A description, in the M3 setting this will be called the M string. And then if you go down to the type 2A, then we have NS5 rings and the B2 rings are suspended between them. And if we again going to the B-compact limit, we will obtain the NS5 turning into N5, and the ND2s are turning into the N and 2 rings. And these D6 are just turning into the place space. So indeed, this type 3 description is turning into the M string configuration in the B-compact limit. But this one again admits the gated theory description. So So we have a 2D 0,4 theory with a UN vector multiples, and one adjoint hyper, and one fundamental hyper, and one fundamental theory. So most of the famous configurations of the self-clear strings in the mid-90s, they can have this kind of Hanani-Witten configurations, so that one can define those the theories in terms of the infrared or red linear of the gauge theories. Okay, so now the question is, can we have some kind of dictionaries or kind of some data about the self-clear string theories? In the mid-90s, many of these kind of self-clear strings, those are realized as the F-theory on elliptic Calabi-Haut-3 with the base P1, and then we have this, the suitable bundles over n. And then in this case, the self-clear string is these three planes wrapping under the Schwenken-2 cycle. This one, this one. So here the n equal 1 corresponds to the E string I just showed before, and the n equal 2 corresponds to the N string. So these admit the gauge theory description. The next simplest one is the n equal 4, which corresponds to this one. If you just look at the geometry of that theory, then one can have the topological type to be orientable descriptions. Essentially, the geometry is reduced to the sigma Z2 with the suitable orientable projections. And there one can easily work out corresponding the spectrum of the 0,4 2D theory, which is given by the SDK times the SOA plus 2P by fundamental hyper and some other methods. So this n equal 1, 2, 4, those are the rather easy examples where one can have either non-Witten configuration type or this kind of the topology and type 2D descriptions. So things are simple so far, but other examples, those are rather non-trivial. And so those are the challenges we should face. Before going into the other examples, I'd like to mention that the F-theory can develop the enhanced gauge group. So I mean, if it has the singularities, then it can have the enhanced gauge group. And in that case, the self-clear string can also be described as an instant string, which has the instant charges. So the above n equal 4 the case is one example. So in that case, the F-theory, I mean, already from the perspective descriptions, one can see that they can carry the SOA gauge group. So in that case, the self-clear string is also the instant strings of the SOA. But more interesting case is the n equals 3, the SU3 case. The subtleties is that we usually know about the ADHM constructions of the SU3. But if you just apply that into the 2D gauge theory, this 2D gauge theory is anomalous. I mean, they have this gauge anomaly. So that means is that in order to describe this one, we need some alternative description of the SU instant moduli space. So far, there will be no general recipe. If some of these NTHU construction give rise to the anomalous 2D gauge theories, then how can you fix to have the right instant moduli space? For those questions, we don't know the general answers. So all of them in these attempts are just to carry out trial and error basis. At least I mean for the SU3, we succeeded, and then the anomaly free the instant string theory, those are given by the UK, the vector multiplies, and plus some additional matters. So we obtained this kind of matter just by the trial and error. I mean, there's some kind of the motivation to obtain this one. There will be the systematic methods to obtain this kind of theory, given some kind of the anomalous 2D gauge theory described the ADH constructions. Okay, so once we are given this meta contents and the suitable interactions, then one can compute, say, the elliptic genus again, and then one can match the elliptic genus configuration or the instant moduli space structure with the known users. So it works. Once you are given this SU3, Then one can obtain the similar theories starting from the SU theories. This one can be generalized with the self-clear string theories of the 60.0,1 theory with errors. One can easily check that these SU theories can be obtained from the SO7 with a two scalar representation. There one can do the Higgsing, then one can obtain the G2 theories with matter 7. And further the Higgsing is 5, then we can obtain the minimal SU3 with no matter. Starting from the self-clear string theories with SU3, then one can go to the de-Higgsing procedure to obtain the self-clear strings with theories with the G2 with the 7 matter and the SO7 with the two scalar representations of A. This can be done. Once we did that, then this construction gives a detailed information about the instant moduli space of SO gauge group with the scalar representation and the G2 gauge group. So this is something new. Now I'd like to mention that this was done in the 6-dimensional context, but there is the similar, the different approach by the Hayashi and the Sung-Soo Kim and the Kim Young-mi and the Fushiaki. They just work out these 5-way wave constructions to obtain the G2, the gauge theories in the 5 dimension. The approaches are complementary to each other. This kind of theories, the SU3 and also the SO7 with the two scalar representation or the G2 with the 7, those theories are very important when we consider the general theories of the 6-dimensional superconducting theories, because those are the part of the atomic constituents of the 60 superconducting theories. So these guys give us some kind of the dictionaries. What kind of the 6-dimensional superconducting theories are available? And then basically they just consist of, or they can be made of, out of this atomic constituents. So let me show the basic building blocks of, such kind of the building blocks of the 60 superconducting theories. So here is this one corresponds to the theories arising from the Calabi-House recompactification over the O-n going into the P1. So we know that for the n equal 1, 2, 3, 4, in that case, those theories, the self-clear string theories, underneath the gauge theory description. So that's good. It's unknown that for these theories, what kind of the gauge theories we should have. Now, in addition to this one, which just has the rank 1 tensor branches, there are more complicated theories with the higher rank tensor branches. So those are classified in this one. You can see that here they contain the G2 gauge theory or the SO7 gauge theories. So just borrowing our results about the G2 and the SO7, then one can work out the corresponding the self-clear string theories corresponding to these guys. So far, what it did is that in addition to these 1, 2, 3, 4 theories, one can also provide the recipes to obtain the self-clear string theory associated with this one. And so the remaining thing is just this one. So that is kind of the current status. How much one can obtain this self-clear string theories out of the gauge theory descriptions. Now, let me just briefly mention about the relation between the partition function of the 6-dimensional superconducting theory and the elliptic genus of the self-clear strings. So it's known that the supersymmetric partition function mostly from the alpha times t partition function of the 60 superconducting theories. They can be written in terms of the elliptic genus of self-clear strings, where this n k denotes the string numbers, and where the I0 is the Witten index of the pure momentum space. So if you're just working out the elliptic genus of the self-clear strings, then one can fully understand the 6-dimensional superconducting partition function. So this one is a very useful one. Now, as I alluded before, this is the elliptic genus of the self-clear string theories. They have the interesting modular properties. Specifically, this elliptic genus, IK, is the weak Jacobi form of the weight zero, and in index IC, where the index IC is completely determined by the Walsh final anomaly of the underlying two-dimensional self-clear string theories. Without even knowing the detailed contents, the meta contents of the self-clear string theories, one can figure out this Walsh final anomalies in advance. So if we know this Walsh final anomalies, then we know that how this elliptic genus IK would transform under the modular transformation, which severely constrains the possible form of this IK. Basically, what we did is to consider the basis for this one and just expand in terms of those. So essentially, the basis for this one is the finite one. So if you just know the input of the finite input of the coefficients, for example, those can be obtained by just working out the gauge theories and work out the separate coefficients of the elliptic genus, or maybe they could be obtained from some other the approaches. Like I'm just looking at the geometries and working on the topological string amplitudes. So there are the various complementary approaches done here. So the previous example of this the elliptic genus of the two string. Those are the simple examples of like this one. So we have just the simple finite basis for the E8 invariant invariant functions, and then one can just completely work out this one using just knowing the finite coefficients. So that's very good. Okay, so let me just conclude. So the upshot is that one can define the tension in the self-clear string theories as the infrared limit of the certain two-dimensional gauge theories. And then once they're given this two-D gauge theory in the proposal, and then one can give the evidences by, for example, by computing the moduli space, or the elliptic genus. As I already told you, we using this kind of the gauge theory descriptions. We know we have known many of these atomic constant theories. But still, there are big unknown problems in this direction, which is to figure out the case with the O minus n going to P1 with n is greater than 4 case. This is also a hard problem because basically those are related to figure out this instant moduli space of the exceptional gauge groups. And also it's obvious that this kind of cases, they also would have no grain constructions. So apparently, in order to tackle these problems, we need more system methods for these problems. So hopefully one can find this kind of approaches, and we can, I hope, to report them in the result very soon. Okay, so thank you very much.
Thank you for reporting us in detail the results and questions, comments. Okay. So this concludes the morning session.